Hey guys, today I want to go over how to find the mean and standard deviation using the TI-84 calculator, and I'm also going to go over how to do the calculation by hand. Feel free to use the timestamps to navigate to the part of the video you're interested in. Here's the problem that we're going to work with. You're given a list of blood pressure measurements of 5 randomly selected adults, and the question asks you to find the sample mean and the sample standard deviation. For this demo, we're using a small data set of 5 values to illustrate the idea, but in your homework assignments or projects, you're probably going to encounter data sets of size 10, 20, or larger. Alright, so let's look at how we can find the mean and standard deviation using the TI-84 calculator. Let's start off by entering the data on the calculator by pressing Stat, then selecting Edit, which is already highlighted, and press Enter. Notice that I already have some data here, and what I want to do is clear this information. You can do this in multiple ways. Let's say I want to clear list 1 or L1. All you have to do is highlight L1 using the up arrow key, press clear, and then press enter, and notice that the numbers under L1 are gone. Be careful not to press the down or delete button because then your list will disappear. If you do, it's not the end of the world. You can recover the list because it's still stored on the calculator. So let me show you how to do that really quickly. Let's say you accidentally delete L2 by highlighting L2, then press delete. Notice that L2 is no longer there. What you can do to recover it is press the second button, then press down to get to INS, which is short for insert. Then you specify the list, which is L2, and it's there again. Notice that the headers of this table are labeled L1, L2, L3, and so forth. I want to clear list 2, 3, and 4. If you want to clear multiple lists, you can go to Stat, then select Clear List, which is option 4. Then you specify the lists that you want to clear, separated by commas. Press Enter. Now let's go back to our table and notice that the lists are all gone. Alright, so let's go ahead and enter the blood pressure measurements in list 1. Now that we have the data entered, press Stat, and then select Calc, then select One Variable Stats. You'll be presented with a menu. For the list, you'll simply provide the list name where you entered the data. In this case, that's L1, which is already there. We'll leave frequency list blank and then highlight Calculate and press Enter. The sample mean is denoted by X bar, which is 132.4. The other measure we're looking for is SX on the calculator, which corresponds to the letter S that we use to denote the sample standard deviation, which is S equals 10.213 if you round it to 3 decimal places. And there you go, that's how you find the sample mean and standard deviation when you're given a list of sample values. If you scroll down, you'll also notice the sample size N, which is 5, as well as the minimum, the first quartile, Q1, the median, and other descriptive statistics. By the way, the last 5 measures are what they call the 5-number summary, and these are used to construct box plots. And I'm mentioning this just in case you're working on that section of the book. Now, if you want to stick around, I want to briefly go over how to carry out the calculation by hand using the table and how we can use a calculator to check our work. The formula to find the sample mean is X bar equals the sum of X all divided by N. Here the numerator represents the sum of all the data values, and the denominator, denoted by N, is the sample size or the number of data values. There are 2 formulas you can use to compute the sample standard deviation. I prefer to use the first version of the formula, but for this video we'll use both. We'll use the first version for now. Let's start by creating a table and labeling the columns. Using a table is a great way to organize the information because 1, it makes it easier to work with, and 2, by organizing the information this way, you're less prone to making mistakes. Now, a question you may have is, what do I use to label the column headers? Well, we label the column headers X and X squared because these terms appear in the formulas for the sample mean and standard deviation. So the first column is going to be the original list of data values that were given to us in the problem, which represent the 5 blood pressure measurements. Earlier, I showed you how to enter this information in list 1 or L1. What we want to do next is create a second column that contains the squares of the sample values of the first column. We can do this manually by typing each value and then squaring each value, but that's going to take too long. For example, I can type in 120 raised to the second power, then type in 136 to the second power, and so forth, but let's not do that. The faster way is to use a formula, so let's clear L2 first, and what I want to do is get all the values of L1 and square them. We can do so by typing L1 squared, press enter, and you're done. Going back to our table, the last row will be used to store the column totals. Let me show you how to get the column totals using list operations. If you want, you can do this manually, but if you're working with a lot of values, this is going to take a while. Instead, what we can do is press second, then press stat to access list, then use the right arrow key to select math. And since we want to take the sum of the column, we'll select sum or option 5. Now we provide the list we want to take the sum of, and that's L1, and we get that the sum of the values is 662. We also want to get the sum of the second column, so we'll go through the same steps. Press second, then stat, select math, select sum, and take the sum of L2, and we'll get 88,066. One thing I want to quickly point out to you is that these values were actually provided to us when we did the one variable stat for L1, so that's another way of getting the sum of the sample values and the sum of their squares. Now that we have the column totals, we can use these values and substitute them into our formulas. To calculate the sample mean, we substitute 662 and divide it by 5, and we get 132.4. For the sample standard deviation, we start by typing the square root symbol, and to make things easier, we'll go ahead and use the fraction template, which you can access by pressing alpha and then the y equals button. This is a really nice feature of the TI-84 calculator because you don't have to worry about screwing things up with parentheses. Okay, so this pulls up a menu. What we want is the first option. Press enter, and we can resume with entering the rest of the information. Press enter, and we get 10.213 rounded to 3 decimal places. For the second version of the sample standard deviation formula, we're going to use a different column header, but note that the first column is going to remain the same. If you look at the formula for the standard deviation, you'll notice that there's an expression of the form x minus x bar, and we can use this as a column header. What I'm going to use instead is that expression raised to the second power. We will get the values of this column by subtracting the mean from each individual sample value and then squaring the result. Let's use the TI-84 to do this step. Let's go to the table by pressing stat and then edit. We have all data stored in list 2, so let's first clear that. What we want to do next is enter a formula for L2. Let's use the parentheses, enter L1, and subtract the mean, which we can access by going to vars, then selecting option 5 or statistics, then select x bar. Let's close the parentheses, then raise this expression to the second power and press enter. Since the summation symbol appears as part of the expression, we want to take the sum of L2 and we get 417.20. Again, we can calculate the sample mean as we did previously. Now let's go ahead and substitute the information into the sample standard deviation, and let's use a calculator for this step. We'll type square root, use the fraction template as we did before, and instead of typing 417.2, I can access this value by pressing second and then the negative symbol to get to ANS, which is short for answer. Then let's divide by 4 and we get 10.213, which matches the answer we got when we used the other version of the sample standard deviation.